Okay, so far the circuits we looked at were either purely series or purely parallel. Notice that this has 3 resistors and they're all neither in series or not all in parallel. And our objective is, given the information, in this case, we're given the resistance of each resistor of the 3 and the battery voltage, we're gonna figure out everything else. Like we're gonna figure out what's the current through each resistor and what's the potential difference, or also called the voltage, or sometimes called the voltage drop across each resistor, okay? So we're gonna figure all of that out. In other words, we're gonna figure out the current in every branch and the voltage across each resistor, okay? So how do I, the question you should ask is, how do you approach this? Start by asking, first of all, what is it that you can calculate right away? You have all the resistors, right? The resistance of all the resistors. So surely you can calculate the total resistance, which means that because the battery voltage is given, if you have total resistance and the battery voltage, you can calculate total current, which basically is the current that goes through the battery and in this main branch. But the question is, how do we calculate the total resistance this time? Which formula to use, series or parallel? All right, now you want to pay attention. First of all, do you think R1 is in series with R2? If you look at those. Is R1 and R2, are they in series? Any thoughts? All right, so let me give you a clue how you figure it out. Follow the current. If the current ever splits and it's not the same between 2 resistors, then they're not in series. So the question is the current through R and R2 going to be the same? Nope, because follow the current. That's the positive terminal. Current goes like this here. Oh, a junction splits. So that's your I total. It splits between I2 and I3. So R1 is clearly not in series with R2. It's also not in series with R3 because the current through them is different. What about R2 and R3? Are they in parallel? Can we say that both of those are in parallel? Again, what was the thing that we said about parallel circuits, that about the current? 2 branches are in parallel if the current splits between them, right? And it is splitting between them. So R2 and R3 for sure are in parallel. These 2 are for sure parallel. So we can start by calculating their total resistance using the parallel formula, which is 1 over R equals, 1 over, in this case, let's do that first here. So the first step is going to be to calculate total resistance of R2 and R3. Which are in parallel. And the formula is 1 over R total. Instead of using R total, which I'm going to reserve for the entire circuit, I'm going to call this one R23, the total for the 2 and 3. Remember, total doesn't necessarily mean add them up. That's why we use the word equivalent as well. For this, the equivalent would be better, but total, it's okay. We know as long as you remember what it means, not just totaling it and adding it. Remember, that's 1 over. Since there are 2 resistors, 1 over R2 and 1 over R3, you add the reciprocal of the 2. I'm also going to show you a shortcut way of doing this calculation. Instead of first plugging in, then calculating R2, 3, you can also do it all in one step on your calculator. If you realize that if you want R23, you also have to take the reciprocal of this whole thing. So first, you're going to do this on your calculator. In a minute, we'll put in the values. And then you go in and you take the inverse or the reciprocal. In other words, whatever you get for the answer of this, you do 1 over that answer to get R23, because R23 appears in the denominator. Is that clear? The negative one means you're taking the right side, and whatever answer you get, you're doing 1 over that answer, right? That's what this inverse here would mean. So let's calculate that. So why don't you all try that on your calculator? Put in these values, 35 and 23 ohms. So your R23 should be like this. There is an inverse button under the math button on your calculator, scientific calculators. If you don't have a scientific calculator, first calculate what's in the parentheses. Whatever answer you get, do 1 over that answer. So you're doing 1 over, I have such a bad memory, I can't even remember what I just said. It was 35 and 23, yeah. 35 plus 1 over 23. Whatever answer you get, take 1 over that answer, which means the same thing as inverse. And you should get pretty close to 14, I think 13.9 or 8 something. I'm just going to round it to approximately, this means approximately equal to 14 ohms. The better way of doing this, and I encourage you to do that, is to keep it all in fractions. I'm just doing decimals today, because then you don't have any rounding errors. Keeping in fractions is always better. So that's approximately 14 ohms. So even for test purposes and stuff, if you do decimals, I'm fine. All right, now we have the total resistance for this, the equivalent resistance of this, right? Now, if you had a circuit like this and you replaced the two resistors R2 and R3 with their equivalent, you will still get the same total current. Is that clear? That's what equivalent means. Like, it's the total or the equivalent that we're getting is a single resistance that if you replace two with their equivalent, the total current which goes through the battery would still be the same, although you will no longer have I2 and I3. In other words, your circuit would basically look like this if I replace that one. This kind of gives us an insight. So I'm doing this, I'm replacing the 2 with R23. This is still your R1. Your I total will still be the same. Now this diagram will help you figure out, is R1 and R23 series or parallel? Are they in series or parallel? Series, exactly. It's the same current, right? This doesn't mean anything. This is just the the wire just bent. That's all. So that's series. Series is easy, right? Equivalent. Now we can find the net, the total resistance of the circuit. You simply add up R1 and R23. Notice that R1 is also 14. This one is actually 14. So it's 14 plus 14. So your resistance is approximately, the total resistance is approximately going to be equal to 28. And the battery voltage is 18 volts. If both of those resistances are equal, the R1 and R23, can you guys quickly tell me what's going to be the voltage drop across R1? So now you're just looking at that series, right? In series, what happens to the voltage? Which thing splits, the current or the voltage? In series. You all figured out from the current, huh? Right, because the current was the same. We said that. Voltage splits. Since the resistors are equal, the split is going to be equal. If they're not equal, then you have to calculate it using the formula V equals IR. You use I equals delta V over R, right? You rewrite that as delta V equals I times R. I'm going to show you that because in many problems, you're not going to have the same resistances. So sometimes students assume that the voltage always splits equally, but it doesn't. Only when the two resistors in series are equal is the split equal. Otherwise, the larger resistance gets the bigger chunk of the voltage. But the two voltages should add up to battery, okay? I'll still write it just because I'm worried that you're just going to assume that the split is equal. I'll do that calculation. So the second step we're doing now is we're calculating delta V across resistor 1. See how I put a 1 subscript under it to clarify that that's for resistor 1. That will be the current in through resistor 1, which is basically I total. You could have called it I1, but I1 and our I total would be the same, times R1. And this should be I total. Let's see. Oh, we haven't calculated I total yet, right? So we're going to calculate that. Okay, so we can work our way the other way around. We can't do that step. For a second, I thought that we had calculated I. Never mind. But this formula can be used to calculate I total. Why don't we do that? Since we just said that the split is equal. Okay. So there is 9 volts, roughly 9 volts here. You will see that if you do exact calculation, you actually get, you know, the exact calculation should be 99. But if you do the rounding errors, I think you should get about, when I did that, 8.4 volts. So don't worry, I mean, it's 8.4 plus 8.4, you know. It's going to be a little off. But like I said, that's why fractions are better. So let's assume that that is going to be 9 volts and 9 volts. If it's 9, then let's use this I equals delta. So instead of writing delta V equals IR, let's keep it in the form I equals delta V over R and calculate I total. I total can also be calculated using the total resistance. So 2 ways of doing that. I total equals delta V of the battery divided by R total. That's one way of getting it. That will mean 18 volts divided by R total, which is 28. And that gives us 0.6 amps. That's one way of getting it. The other is just to apply it to the resistor 1 or to resistor R23, the equivalent resistance. And you'll still get pretty approximately the same answer. Not exactly because we rounded. All right. So now we've got everything for this resistor. We've got this, we've got the voltage, we already know R1. Now focus on R23. R23 in our actual circuit are 2 resistors, right? So let's see if there's something else we can figure out. Remember that for each of those resistors, if we know 2 out of the 3 variables, I, delta V, and R, we can figure out the third. We have R. We know that the total current towards them is I total, but we don't know the individual currents, right? Is there anything else you can tell me about parallel circuits? So the other clue we have is there's a 9 volts across. What that 9 volts we got in this diagram means that if you had a voltmeter and you placed it, let's see if somebody remembers that rule. If you place the voltmeter here and you consider these two as just 1, you would find 9 volts. All right. Can someone tell me? Obviously, the current is going to split and the split is not equal because the resistances are not equal. Does anyone know what that clue might be that helps you? Without doing a calculation, you can tell me actually. Based on something you know about parallel circuits. I'm giving you hints upon hints. Uh-huh. Huh? They do split the current, right? But the current is not equally split, right? So how do we calculate that? We can do it in a different way too with considering ratios. I'm not going to go there. Anything else that you also know right away? What do we know about the voltage across these two? How does that compare to 9 volts? If the current splits, does the voltage split? It was the other way around. No. If the voltage doesn't split, what's the voltage across R2 and R3 then? So in this case, it's actually 9 because 9 is what we have across these two. All right, if we did not have R1 in the type of problems we did yesterday, if there was no R1, then yes, it would be 18. But since first the voltage split between R1 and R23, whatever is across R23 is equal, like it's not split, it's the same across those two. So there's 9 volts, you can write it here, 9 volts here and 9 volts there. All right. Now we have 2 out of 3 variables for each of those. Let's calculate current. So for resistor 1, for R1, I1 will be delta V1 divided by, sorry, not R1, R2. I'm not looking at my diagram. So we already know everything for R1 now, over R2. And delta V2 is 9 divided by, what is the resistance of the second one? It is 35. So 9 over 35. I'll let you calculate that many amps. And then for R3, you can leave your answers in fractions too, by the way. That's better, like I said. And then I3 would be delta V3 divided by R3, which is 9 over, is it 23? 23, yeah. 9 over 23. That many amps. And they should add up to roughly 0.6 amps, the I total. All right. And I think we have done all the calculations. Let me shrink all this. We're ready to fill in those blanks with all this information, right? These blanks are basically all this stuff that we've just calculated. I1, we have 0.6 from here. You can put that there. I2 is that. I3 is this. But anyways, it's all here. Delta V1, delta V2, delta V3, they're all 999, right? All right, so I'll shrink this just in case if anybody needs to take a, if you want to take a screenshot, I will also share this video link later on. Okay. Now, let me tell you today how I want you to work on this, which I think will be helpful for you. After this page, I want you to go, for now, you're going to come back to this page, but start first with this page. You're going to see some patterns here. You're going to calculate the total resistance for all of them are parallels, okay? That's 2 parallel resistors. That's basically in these diagrams, they have not drawn the entire circuit. The entire circuit would have looked like this with a battery. The point being, we don't care about battery or in the current. All we care about is, can you use the formula 1 over R equals 1 over R1 plus 1 over R2. And if you have a third resistor, add the extra term plus 1 over R3. Can you use this formula to calculate the total resistance? You're going to see a pattern here, which later on when you do the problems, you're going to quickly be able to just do that. So let's see if you can see that pattern. So do this one first. Then after this, I want you to jump to the next page, will be the better one, yeah. Do this, and then finish the rest of the worksheet, which we will have time to do tomorrow. Today, if you can do these 2, I think that will be pretty good. All right, go ahead and get started. Let me know if you have any questions.